Okay, so this is supposed to be a warm-up. If we had more time, I would actually give this to you as a warm-up, or maybe I have, I don't know. So for the examples that are on this page, we're going to focus on examples A and B at the top, so 1A and 1B. I'm going to do A with you. Question B, I'll help you with setting it up, but you guys can finish solving that at a later time. So for example 1A, let me zoom out a bit. This is asking you to, given sine of theta is 7 over 11, you need to find all of these trig functions here. So find the indicated ratios given theta is an acute positive angle. So acute positive angle means that it needs to be in the first quadrant of your unit circle and on your graph. So your triangle would look something like this, since it's a acute positive angle. And anytime you're drawing this out, you want to have theta closest to your origin. Okay, so we need to think back to sine. If you think back to the notes that we did over sine, cosine, and tangent, we've been doing that quite a bit lately. This is your notes from last time. Sine is opposite over hypotenuse. So I'm just going to use that to help me with graphing it. So sine is opposite over the hypotenuse. So from theta, which is here, I'm going to go opposite of that, which will be 7, to the hypotenuse, which is directly across from your 90-degree angle, which is 11. This is not a Pythagorean triple, but I need to find out what this angle or what this side length is. How would I find it? Pythagorean theorem. So over here to the side, we're going to do a squared plus b squared equals c squared, and we're going to solve. So a, it doesn't matter which side you give it. I'll say a squared is the unknown. B squared is 7 equals, not plus, equals c squared, which is 11 squared. Okay, so I'm going to add 49 with a squared. And 11 squared, this is not 112. Make that a little smaller. 11 squared is 121. I'm going to subtract 49 on each side. A squared is going to equal 72. Double check my math. Is 121 minus 49 72? Okay. Last thing I need to do is square root. Don't give me the decimal for this. You guys already know I'm going to want a simplified radical. So to simplify this radical, I would break 72 into nothing but prime numbers. This is my way that I used back in Algebra 2. I think some of the other Algebra 2 teachers use this. I need two numbers that multiply to 72. What two numbers can I use?
6 and 2.
Which 6?
36 and 2.
36 and 2? 2 is prime. 36 I can break into 6 and 6, which each of those 6's break into 3 and 2, 3 and 2. Technically, you don't need to split all of this up here. You could just take the square root of 36 and then simplify from there. But this is in case you forget how to do that on a test or quiz. You can always use this. There are 2 3's and 3 2's. I always call this my little radical prison. So I'm going to help little prisoners in this little radical prison escape. The index on this radical is a 2. So if I can make a group of 2 of the same number, I can help those numbers escape from this little prison that it's in. So as I help these 2 numbers escape, only one of those numbers in each group is going to make it out. So the 2 numbers that escape are 3 times 2. Well, what's 3 times 2? And notice that the square root of 2 is still underneath. That's why I said you could just take the square root of 36 because the square root of 36 is 6, and you still have 2 under your radical. So maybe write this. A is equal to the square root, let's try that again, 6 square root of 2. A is equal to 6 square root of 2. So I have this. Let's go ahead and use it to label our remaining trig functions. So cosecant. If you forgot what cosecant is, we're going to look at your little chart that we did last time. Even though we don't have a radius, it's still technically considered your hypotenuse. And I could draw a circle around this, but I'm not going to waste time with that. So for cosecant, we're going to do hypotenuse over opposite, which is pretty much the reciprocal for 7 over 11. So hypotenuse over the opposite, which is going to give me 11 over 7. I literally just did the reciprocal for this fraction, or you can actually look at your diagram. Hypotenuse over the opposite side from theta is going to be 7. That should be your answer. For cosine, cosine is, if you think back to your notes, that's adjacent over the hypotenuse. So we're going to write this as adjacent over the hypotenuse. So from theta, adjacent is here over the hypotenuse, which is 11. Whenever you need to rationalize, is it when your radical's in the numerator or the denominator? Denominator. Okay, so I don't need to rationalize this, so this is my answer. Last one is tangent, which in SOHCAHTOA is going to be opposite over the adjacent. So opposite over adjacent. So opposite over the adjacent, that's 7 over 6 square root of 2. Do I need to rationalize this? Valeria, how do I rationalize 6 square root of 2 in the denominator with a 7 in the numerator? What do I do? Multiply by the square root of 2 on the numerator and denominator. So that's going to leave me with 7 square root of 2 over, in the denominator, you're going to have 6 times square root of 2 times the square root of 2. But what's the square root of 2 times the square root of 2? Just 2, because 2 times 2 is 4. When you take the square root, it's just 2. Can I cancel these 2's? But they're both 2. Why not? Why can't I do it? Not just different, well, technically different exponents, because this one's a radical, which means it's to the power of the 1/2. This one has no exponent, well, really just a 1. So since this one's under a radical and this one isn't, you can't cancel those guys, no matter how much you want to. So write your answer as 7 square root of 2 over 12. That's your final answer. Don't try to simplify it because you can't. I'm going to start you off with B, but you can easily finish it. You're finding these trig functions, and if you forgot what those trig functions stand for, we literally did a chart, and we're going to probably do a few more charts like this for your trig functions, sine, cosine, tangent, all the way through cotangent. Okay, so for here, we have cotangent. Okay, that's definitely not one of my normal trig functions, but I do know from the page that I just showed you guys that cotangent is opposite, just kidding, it's adjacent over opposite. So if you were to draw this out, remember it still has to have a positive angle. So that's why I need to put it in the first quadrant. We're going to do adjacent, which is here, over the opposite side, which will be 5. So this should be my graph. When you have time, if you want to do this, find your hypotenuse and then identify all of these ratios for your sine, secant, and regular tangent. All right, let's look at example 2. So in example 2, this one says let negative 2, 3 be a point on the terminal side of theta, and then find the indicated ratios. So again, let me draw out a coordinate plane. Negative 2, positive 1, 2, 3 is going to be somewhere here. Remember, this is technically enclosed in some kind of circle. And what I need to do is find out what these ratios are. On the last problem, the reason why I was able to just quickly draw a triangle without necessarily needing the circle is because it was technically in its trig function. We already know that, especially since it's cotangent, it's talking about a 90-degree angle. This one, by just giving a point, we don't have an angle. We don't know if it's going to be a sine, cosine, or a tangent that's giving me this point. So I'm going to drop this down to the x-axis, make it perpendicular, and I'm going to label the sides that I have. I went to the left, negative 2, and I went up 3. So theta should be inside of your triangle, very close to the origin. I need to find the hypotenuse. So let me redraw this. This is negative 2, 3, and theta. And what I want you guys to do right now is solve for the hypotenuse. Solve for the hypotenuse and then answer cosecant, cosine, and cotangent on the far left. I'll give you guys about 2 minutes. Giselle, what's theta going to be? Or excuse me, not theta. Giselle, what's your hypotenuse here? Not theta. Square root of 13? Okay, so give me the cosecant ratio. 3 over the square root of 13, like this. You sure? Let's look back at our notes. For cosecant, which is CSC, this is the hypotenuse over opposite. So we need to flip the fraction that you guys, or you're thinking for sine, and we need to do it the other way. It's okay. So that's why I was writing out next to it what you're actually finding. So if you need it, you have it. So for cosecant, this was, I said hypotenuse over opposite. So let's try that again. What did you say the hypotenuse was? Over 3. There we go. Okay, for cosine, Itzel, what did you get for cosine? Ooh, you had to rationalize? Yes, that's exactly it. -2 square root of 13 over 13. And then the last one, cotangent. Chelsea, what did you get? -2 over 3, no radical? Yep, that's okay. That's your answer. Okay, so we've refreshed your memory a bit on these items. Let's look at example 3. Example 3 is fairly new, so let's talk about what this is, and then we'll look at some practice problems with it. Okay, so degrees, minutes, and seconds is the last little topic that we need to talk about, at least for this page. So with degrees, minutes, and seconds, if you Google, literally Google DeBakey High School, you will see the degrees, minutes, and seconds. If you actually type in degrees, minutes, and seconds for DeBakey High School, it'll pull up with our high school and the location where it is in the world using the satellites that are out in space. You can do that for your house. You can do that for your barbershop, your fast food restaurant you like the most. It can do it for any location in the world. So what we're going to do is figure out why that happens and how you can find those things by hand and using your calculator. So with these items, we're going to focus, at least right now, for triangles, but we are going to probably be able to use this for a few other things maybe. So for the degrees, minutes, and seconds, we're going to need some conversions because we're going to be given items with degrees, and we need to discover what it is for the minutes and seconds as well. Okay, so I talked about this last class. 1 revolution is what? 360 degrees. We wrote that. That was one of the first things we wrote on our notes. 360 degrees is 1 revolution. That means it goes around your circle 1 time. So this is equal to 360 degrees. 1 degree, this little symbol here is a degree, is equal to 60 minutes. And minutes is going to be written, as you notice here, this is in degrees, minutes, and seconds. We're going to put 1 degree is equal to 60, that little hash mark. So it's the same little single hash mark that I have next to this 8. This little hash mark means minutes. And then the last one is 1, what does this hash mark mean? Minute. 1 minute is equal to 60. What was the other unit we need? Seconds. And for seconds, we're going to put the little double hash mark. So 1 apostrophe is going to equal to 60. It's almost like a quote symbol. It's like the quotation. These conversions are going to be useful to us for the rest of the class period. So let's start by looking at example A. We're going to use these conversions and your knowledge of dimensional analysis to find our answers. So first question, it says to convert the 70 degrees, 8 minutes, and 32 seconds into just degrees. You just want degrees. Okay, well the cool thing is there's only one number here that's actually a degree. What number is that? 70. So the degree, label that first, is going to be 70 degrees. The next thing we're going to need to do is convert 8 minutes into degrees. So let's look at the minutes. Okay, so there are 8 minutes in this problem. How do I convert this into degrees? How do I use it? Okay, so dimensional analysis, so I made my little chart. What conversion should I use from the top? Say it again. Okay, well, 1 what?
Degree.
1 degree over the 60 minutes right here. So we're going to put 1 degree over the 60 minutes. Remember, the whole point of doing this is so these units can cancel. That apostrophe is minutes. And we're going to set that equal to 8, not 80, 8 over 60 degrees. We're going to use this in a second. Don't use your calculator yet. So let me box what I have. I have this. I have my 70. Let's find the seconds. You have a brain, guys. Use it. We have 32 seconds. You guys do the conversion. Use the table or the chart and the conversions I just gave you to try to figure out what the degrees will be for this. So as you can see here, there's not just a direct correlation from the seconds right into degree. We have to go from seconds into minutes, and then from minutes into degrees. So we're going to make this 60 seconds is equal to 1 minute. I'm going to cross out those units. Keep in mind, this elongated apostrophe is not degrees, so I need to make this into degrees. I'm kind of shortening that. So I'm going to use the 60 minutes is equal to 1 degree. So 60 minutes is equal to 1 degree. And I'm left with 32 over 6 times 6 is 3,600. This is in degrees. Remember, the problem said that you want your answer with a decimal in degrees. So my last step is I'm going to use a calculator, and I'm going to literally just add 70 degrees plus 8 over 60 degrees plus 32 over 3,600 degrees. It doesn't matter what form your calculator is in for this because you're just calculating a value. You're not using trig to find an actual degree. This is just giving you the degrees in a decimal form. So in your calculator, I'm going to turn it on. I'm going to go into the new document, not Scratchpad because I don't like Scratchpad. And we're going to add 70 plus 8 over 60 plus, keep in mind, guys, you can make a fraction if I haven't told you. Hit the control button and the division symbol, and it makes a whole fraction for you in case you want to use it that way. Okay, let's hold up a second. This gives me a fraction. I need to get this into decimal form. Do you guys know how to get this into decimal form? Mm-hmm. Control enter? Yes, that can work. Hit control enter and that will work. If not, you can push, I'll do it for the other one in case you want to do it the other way. If you have this fraction and you don't remember to do control enter, you can use menu. Scroll down to item 2, which is number, and then it literally says to convert to decimal. You can approximate a fraction, a bunch of different things. So that will also give you the exact same answer that we got. So let's write down our decimal. This is 70.1422. Thank you, Gabrielle. All right. On the next part, this second part, B, has already given us this ugly decimal, but we need to get degrees, minutes, and seconds just like this. So what I'm going to do is I'm going to have to work backwards. So my first step is still going to be the same thing that we did before. What's the degree in that problem? 38. So let me actually write out in front of this degree. So degree, this is 38 degrees. The next thing I need is my minutes. The issue is, and you guys can look at the decimal for this that we just got, this decimal is a combination of 2 different numbers. It's a combination of the minutes and the seconds. So what do you guys think we could do from the minutes to get it into, from this decimal and get it into minutes? What should I probably use? I used the 38 already. What have I not used from that decimal? The 6, just a 6? 628. Let's use that 0.628 because remember, that's a combination of the minutes and the seconds, and let's convert it. Right now it's in degree. So now we just need to convert it from degrees into actual minutes. Yes, ma'am?
How do we know there's a combination?
Because we just did that here. Remember when we added these 2 fractions, we got this decimal added? 70 degrees, that's here, right? And then the 8 over 60 plus 32 over 3,600, that's going to be a combination. That's why I have that whole crazy decimal. Is that okay? No, that's a good question. So that's why I'm having to split this up. So we're going to use the conversion at the top to get it into minutes. We're going to do 1 degree is equal to 60 minutes. For this one, we can actually use a calculator because we're not going to divide it yet. So I'm going to do, these degrees cancel, 0.628 times 60. That's going to give me 37.68 minutes. I only need the 37 from this. This is in minutes, right? I only need the 37 from this. That's the number of minutes that I'm going to have. So let me write out pretty much my answer. So for step 4, I'm going to start writing this out so we can start pulling out the pieces that we need. We're going to have 38 degrees. We're going to have 37 minutes. How am I going to find the seconds? What should I use? 0.68 at the end. Let's use this for step 3, which is to find the seconds. So 0.68 minutes. We're going to convert that into seconds. And this is in degrees. Oh, no, sorry, that's in minutes. Okay, so we're in minutes. Let's get to seconds. I'm going to use the conversion at the top. 1 minute is equal to 60 seconds. I can multiply. So far, so good? All right, so 0.68 times 60 is going to give me 40.8. So 40.8, and this is now in seconds. There's probably smaller units like, I don't know, milliseconds or whatever time unit is less than a second, but I only need degrees, minutes, and seconds. That's what the S stands for. So there's 2 ways you can write this. You could either leave it as a decimal, which is 40.8. You would just stick that here, or you could round it up. I'm going to round, and on your tests and quizzes, I'll probably also have you round that as well. So just put it as about 41 seconds. This that I'm boxing would be your answer. So those are my 2 answers for this page. Before we look at the last thing that we're going to talk about, go ahead and flip this page over really quick. Flip it over. The whole back side of that page is extra practice. So all of these questions, if you're like, I really don't understand how to do degrees, minutes, and seconds. Oh, congratulations. Pick the form you don't like and do those. The great thing is the answers are right next to it. So you got plenty of time to get those done. All right, before we move on, any questions about A or B? All right, cool. Let's look at page 49. So get this one out really quick. All right, so on this page, we technically already did this a little bit when we were reviewing regular how to solve triangle stuff. We already did that before. What we're going to do now is we're going to actually answer those questions that I skipped over because now you guys know what to do. Okay, so for question 2, this is in, if you look at this angle, it's in degrees, minutes. What's missing? The seconds are missing, right? Okay, yeah, that seconds is missing here. So we're going to need to convert this from degrees, minutes, and seconds into just a degree. So I just want a decimal like we did right here. So we're kind of doing the stuff that's in blue. Okay, so on this side for question 2, I'm going to kind of put some steps over here along the side just so you guys have it in case you forget what to do after break or after a weekend. Okay, so step 1, you guys already have agreed, we need to convert to decimals, or not decimals, excuse me, degree. Specifically, decimal degree. Okay, so first thing I need to do, first step, part 1 is to label the degree. I'm literally doing the same steps that we just did in blue on this page. I'm literally doing the same steps. So the degree for this, we have 60 degrees, 15 minutes. That's 60 degrees. 2 is the minutes. So we have 15 minutes that I need to change into degree. Which conversion should I use to change that? Okay, so what's the conversion? 1 degrees over 60 minutes. So this first one right here. So we're going to make this 1 degree over 60 minutes. And I'm going to rewrite this as 15 over 60 degrees because both of those units cancel. Part 3 is usually the seconds, but do we have any seconds here? No, so I'm just going to put 0. So step 4 is just to add all of those numbers up. We're going to have 60 degrees plus 15 over 60 plus 0. Let's be honest, I don't need to add that 0, but I put it there just in case. And my calculator, I'm going to go ahead and plug this in. 60 plus my fraction, 15 over 60. And we don't have to put plus 0. And from here, we're just going to approximate. Hit Control, Enter, and our degree as a decimal is 60.25. Carlos, am I done? What else do I still need to do? No? All right, my seconds were 0. What did the problem ask me to do? Read the top. Solve for x, and then we're going to round to 2 decimal places. So my last step here, step 2, is to solve for x. So using the 60.25, Carlos, which trig function should I use to solve for this x? Sine, cosine, or tangent? I'll write that on the top. SOHCAHTOA. Which one? Sine. So opposite over hypotenuse, I agree. So step 2, we're going to do sine of 60.25 is going to equal opposite over the hypotenuse. I'm going to cross multiply. So 15 is going to equal x times sine of 60.25, and then I'll divide both sides by sine of 60.25. So x is going to equal, I'm going to rewrite that fraction just so you see what I'm typing in. I'll move my paper in a second. And before you get excited and start plugging it in, what's wrong with my calculator? It's not in degree mode. So go into doc, go down to option 7, which is settings and status, go to option 2, and then change it from radians into degree. If you don't do this, guys, you're going to get your answers wrong every single time. All right, so I'm double checking. It's in degree. Let me write my answer in. So we're going to have 15 divided by, we're going to do sine, so trig function sine of 60.25. I'm lazy. I don't feel like recopying it. I'm just going to hit control and the negative symbol. It's going to recopy the last answer. So if you hit control, the gold button, and the negative symbol down here, it's going to recopy whatever your last answer is. So x should be equal to 17.2771. And my units here are in feet. That should be your answer. Right now, you guys start off example 3. Get this from degrees, minutes, and seconds into just a degree as a decimal. So do number 3 right now. If you finish getting it into degrees, minutes, and seconds before I go through it, cool, finish it. So we're going to use the steps that we learned in the last problem to try to find the value of x. So the first thing we're going to have to do, like we said before, is to convert this into degrees, specifically a decimal degree. So we're going to take I'm going to rewrite 12 degrees with 30 minutes, and we're going to go ahead and convert. So the degree is going to be 12 degrees. That's number 1. Step 2 is for the minutes. And in the minutes, we're going to do 13, or not 13. Let's try that again. Let's make that 30 minutes. We're going to do the conversion like we did above. 60 minutes in 1 degree. The minutes are going to cancel. And we're going to be left with 30 over 60 degrees. All right, so let me box what I have, mainly just so I don't lose it since I'm running out of space. 3 is the seconds. Well, there are 0 seconds, so that's going to be 0 degrees. And I'm going to just combine everything that I have in my little step 4. So using my calculator, we're going to go ahead and get this guy out. We're going to add 12 degrees plus 30 over 60 degrees plus 0. Just like we did before, we don't have to add that 0 degrees into our equation, but I'm going to at least put in the first part. So 12 plus the 30 over 60. And that's going to give me my decimal. We're going to use Control Enter to approximate that decimal, which will be about 12.5 degrees. Okay, so that's my degrees. What I need to do now is figure out which trig function to use to actually solve for x. So the only trig function that I think will be helpful, we have an adjacent side and we have a hypotenuse. This is directly across from your 90-degree angle. So we're going to go ahead and use the adjacent and hypotenuse. Let's go ahead and use cosine. So big step 2, we're going to use cosine of this angle, which we just found was 12.5 degrees. We're going to set that equal to the adjacent over the hypotenuse. And we're going to go ahead and solve. So multiplying each side by 55, x is going to equal 55 times the cosine of 12.5 degrees. Let me double check. My calculator is in degree mode, so that's good. We're going to have 55 times cosine of 12.5 degrees. So we're going to make this 53.6963. I can round that to about 53.70, and that's in feet. Make sure when you are rounding that you, especially since this one was 69.6, I'm going to round up. So make sure that you put that 0.70 as your decimal. So 0.70. Okay, so let's look at a couple of other questions. And the next one that I want to look at is question number 10 on the next page. Before you flip, you see here how there's that random 28 at the bottom? That 28 is really from question number 6. So for question number 6, up here at the top, this is the 28 feet. For some reason, it was moved to a different page. Let's go ahead and look at number 10 at the bottom of the page. The question saying solve the value of theta in degrees, minutes, and seconds. So here's theta. Theta is in this little corner, and I need to figure out what this is going to look like in degrees, minutes, and seconds. It's an angle measure, so let's try to figure out what we're going to write. First thing I need to do is figure out which trig function I should use. Okay, so I have sine, cosine, and tangent. I have the adjacent side and the opposite side. This is my hypotenuse. So let's go ahead and use the tangent of theta, which is going to equal opposite over the adjacent, and we're going to solve. Well, let me think. In order to get the the theta by itself, I'm going to have to do the inverse of tangent on each side. Remember, we did this a while back. Whenever you're trying to find an angle, you're going to do the inverse, tangent inverse. So theta is going to equal tangent inverse of 12 over 25. And I'm going to use my calculator to solve. So we're going to do tangent inverse of 12 over 25. I'm going to put that fraction, 12 over 25. We're going to get about 25.641. So theta is 25.641. As you're going to notice in your calculator, if you were to scroll up and hit enter, it's going to give you a lot longer of a decimal. For right now, we're just going to use those 3 decimal places. We don't need that whole crazy long decimal. Not right now. Okay, so I need to ask myself, am I done? Did I solve for theta? Okay, well, if I look back at the question, it says solve for theta in degrees, minutes, and seconds. This right now is in degrees. I need to get this into degrees, minutes, and seconds. So what I need to do over here to the side is actually solve. And I'm going to zoom in a little bit. So I'm going to take the 25.641 degrees. In step 1, we need to identify the degree. That's 25 degrees. Step 2, we need to convert this from from degrees into minutes. So like we did before on the last page, we're going to take that 0.641 degrees and we're going to convert that into minutes using the conversion from the last page that we were on, where 1 degree is equal to 60 minutes. So let me go ahead and use my calculator. I can cancel out my units. Make sure you cancel those. 0.641 times 60. So we're going to make this 38.46. That's in minutes. Okay, so remember, our answer for this question is going to be in degrees, minutes, and seconds. I'm going to kind of skip down to part 4 where my degrees, minutes, and seconds answer will be. And I'm going to put the 25 degrees. And from here, we're going to use the 38 minutes. This decimal, 0.46, is going to help me with finding the seconds. So we're going to take that 0.46 minutes Remember, this is a minutes, that's an apostrophe. And we're going to convert this into seconds. So in order to convert this into seconds, we're going to use 1 minute is equal to 60 seconds. And we're going to use our calculator. Don't forget to cancel your units. 0.46 times 60 is going to give me 27.6 seconds. Remember, we just talked about this on the last page. This 27.6, I might leave it as an answer as a multiple choice test or quiz question, but I would definitely just round it for now. You can always recopy it if it's a multiple choice question, or if I explicitly put in the directions to round it to the nearest tens place. But for now, we're just going to put 28 seconds and write that as our answer. So this guy here will be my solution. Right now, I want you guys to get a head start. Do number 11. Give you a quick minute head start. Do number 11. So with question 11, first let's identify our hypotenuse. That's right across from your 90-degree angle. So let me think. If I have the hypotenuse and the opposite side across from theta, we're going to have to use sine. So sine of theta will equal opposite over the hypotenuse. You could technically simplify 3 or 30 over 4, but remember, you have a calculator. Save that work for the calculator for later, because I find it when students find things way easier than they think it is, they'll start making more mistakes. So just leave it as 30 over 40, and we're going to cancel out the sine, not by dividing, but doing sine inverse instead. And we're going to rewrite this as theta, which will equal sine inverse of 30 over 40. So in my calculator, we're going to do sine inverse of 30 over 40. Remember, I don't have to put the fraction in there. I'm just putting it in as 30 divided by 40. It's going to give you the same answer. And this is going to give me a theta of 48.5904. Again, am I done? Well, if I look at the directions, it again says to solve for theta in degrees, minutes, and seconds. So for the 48.5904 degrees, I need to get this into degrees, minutes, and seconds. So you should have taken that 48 degrees. That's your degree. Let me actually put degree first. Degree, that's 48. The minutes, we're going to take that 0.5904 and we're going to convert that from degrees into minutes by using 1 degree, 60 minutes. I realize that I might be moving a little fast, but guys, I asked you to do this, and dimensional analysis you did back in IPC and Algebra 1 and middle school, so you've seen this a while. So we're going to make that 35.424 minutes. And then for my seconds, we're going to take the decimal here, which is 0.424 minutes, and we're going to convert that into seconds using the same conversion from above. So 1 minute is equal to 60, I was about to put degrees, 60 seconds. That's a second. So we're going to take our calculator, 0.424 times 60, and that's going to give me 25.44. So from here, we're going to go ahead and continue to simplify. And this is seconds. We're going to write out our answer. I'm going to move it all the way over here. So the fourth step, which is writing our answer, we're going to write this as the 48 degrees, the 35 minutes, and, okay, we have 25.44. So 44 is close to 0.5, but it's not at 0.5. So we're just going to leave this as 25 seconds instead of rounding it up to 26 seconds. The only way I can think of being consistent on y'all's tests and quizzes is doing just the basic rules of rounding. Instead of having this as any number, just round up, we're just going to keep it as 5 and up. You're going to round up, of course. So we're going to make that 25 seconds. So this guy here should be your answer. So what we're going to do now is we're going to go ahead and look at a few more questions. And one thing that I want you guys to realize is we've been using this lovely calculator for the past several minutes. You know you can do all of this in your calculator, right? You don't have to do all of this by hand. I always show you guys what to do by hand first, so that way you don't have to worry about trying to figure stuff out the more difficult way later on. So now that you guys know how to do this by hand, let's look at a question that we can use in our calculator. So let's start with question 7. I'm just moving up the page. So question number 7. And we're going to solve for x using the degrees, minutes, and seconds that are here. So for question 7, let me give myself some space. So for question 7, first thing I need to figure out is what trig function to use for this angle. Okay, so this is the adjacent side. This is opposite because the hypotenuse is here. We're going to need to use tangent. So tangent of 30 degrees, 45 minutes, there's no seconds, is going to equal to opposite over adjacent, which is x over 53. We're going to solve. I'm going to cross multiply. So x is going to equal 53 times tangent of 30 degrees and 45 minutes. Let me show you how to plug that in your calculator. And remember, instead of cross multiplying, if you want to multiply both sides by 53, that's just basic solving. Let me put this all in the same frame. Okay, so let's go ahead and plug this in. Double check that your calculator's in degree mode. We're going to do 53 times tangent of 30 degrees and 45 minutes. So look up at the screen so that way you can see. I am going to push to get the degrees, minutes, and seconds. I'm going to push the button here that's for your catalog next to 9 and the open book. So hit that. And we're going to select the second row, second column. It's already highlighted in blue on my screen. Once you have that selected, hit enter and you should see degrees, minutes, and seconds pop up. So hopefully y'all can see that. So in your calculator, you have the degrees, minutes, and the seconds. Okay. I know it's a little difficult because of the glare, but there's a little degree symbol, there's a little minute symbol, and there's a little second symbol. So we're just going to take those numbers that we have here. Let me scroll over. We're going to take these numbers and we're going to plug them in. So we're going to have 30. I usually will tab over, so hit the tab button right here in order to get from one number to the next. Let me zoom out and see if that makes it better. That doesn't. I'm sorry, guys. I'm trying to make this the best that I can. So we're going to have 30 degrees, 45 minutes, and again, there are no seconds here. So there's no number behind it, so we're just going to put 0 seconds. So once we have that typed in, we're going to go ahead and hit enter. And our decimal is going to be 31.5317. If you think back to the problem that we just did, that was finding a side length, and decimals are okay. So I'm just going to round that. X is going to be approximately 31.53, and this is in feet. Pretty easy, right? You guys were able to use your calculator. Let's try that again. Y'all were able to use your calculator to actually find that angle measure without having to do that crazy tedious conversion that we just did before. So let's do this on a few more questions to see what we're going to get. And let's go ahead and look at questions 14 and 15. So I'm going to flip this over. We're going to look for questions 14 and 15. With questions 14 and 15, we are solving for the value of theta in degrees, minutes, and seconds. Okay, so here's theta for question 14. Okay, so what I need to do is I need to figure out which trig function to use. At the top of my page, I always write out SOHCAHTOA just to make it easier. And I need to relate this to which angles I'm going to find, or which side lengths I have to help me find my angle. So for this question, I have to zoom out. Right across from the 90-degree angle, that's the hypotenuse. So we're going to go ahead and say that we have the opposite and the adjacent side, so we're going to use tangent again. So tangent of theta is going to equal opposite over the adjacent. I'm going to go ahead and solve. So in solving, I'm going to do the tangent inverse on each side. These tangents are going to cancel. So theta is going to equal tangent inverse of 21 over 18. Okay, cool. I have an angle measure. Let's plug it in. I don't know how the degrees, minutes, and seconds are going to work, but we're going to plug that in. So we're going to have, I'm checking its degree mode. We're going to put in the tangent inverse of, you can put a fraction in if you want, 21 over 18. So theta is going to equal 49.3987. We've done this pretty much for a while now. We have shown you, or I have shown you, how to convert from the decimal, which is in degrees, into degrees, minutes, and seconds. We've already been doing that. What I'm going to show you now is how to have your calculator do all of the hard work. So don't tell me, oh, Ms. Toppy, I don't want to have to doing it by hand anymore. I want to be able to use a calculator. Yeah, that sounds all fine and dandy, but if I give you a test or quiz and I don't give you the graphing, let's say I give you the scientific calculator and I ask you to find the decimal, or the degrees, minutes, and seconds, I want you to actually do that work. So in your graphing calculator, to get this into degrees, minutes, and seconds for theta, I'm going to push the following buttons. So the first thing we're going to do is we're going to scroll up, highlight your answer. Oh my gosh, guys, this glare, I'm so sorry. Highlight your previous answer. We're going to hit enter. And I want to make sure that I have a degree symbol here. So on the bottom part of your calculator, right down here where this question mark is, you're going to push it. And it's going to pop up with a question mark, exclamation point. The fourth option is a degree symbol. Hit that degree symbol, and it's going to pop up right next to your decimal, which is perfect. From here, you're going to go to the open book, which is next to your catalog. So go to the open book, which is right above the division symbol. So you're going to click on that. And you are going to go to, if it's already not in your calculator, you're going to go to you're probably going to be in the first one. Try to get to where you guys probably are. You're going to be in the first one. You're going to highlight. As I'm kind of tabbing over, I'm just hitting the tab button and I'm highlighting. Notice that it has a black circle or black square around it. You want to highlight the first column and literally just arrow over. Just click over once. Look back at my screen. I'm going to show you how to get to the next part. You're going to scroll down to number. It should highlight in blue. Go down to angle. Go down to angle. You're going to hit enter. And you're going to scroll. So after you hit angle, enter, open it. Looking at me, looking at the board. You're going to scroll all the way down, keep looking, to convert DMS. That means convert to degrees, minutes, and seconds. So go ahead and scroll down, get to convert degrees, minutes, and seconds in this second tab. Hit enter, and then hit enter again. We're going to do this for one more question, so in case you got lost, I'll do it one more time. So we're going to have 49 degrees, 23 minutes, and 55 seconds. Didn't have to do the whole crazy conversion. That's it. I'm done. All right, let's look at question 15. So for question 15, you can go ahead and try to start it if you want to. Give yourself a little bit of a head start. Try to set this up on your own. Okay, so let's identify what we have. Right across from the 90-degree angle, we have our hypotenuse. Okay, so the hypotenuse isn't labeled. So I could have done this for the other question too, but there's no point. I could have done Pythagorean theorem to find the hypotenuse, but unless the question explicitly asks for the hypotenuse, guys, don't waste your time. Use the items that are given, go from there. So in here, I have the opposite and the adjacent side. So goodness, tangent's getting a lot of attention today. So we're going to use tangent. And we're going to do opposite over the adjacent. And I'm going to isolate, get a different color, going to isolate the theta by doing tangent inverse on each side. So theta is going to equal tangent inverse of 12 over 32. Let me write that out. So in my calculator, we're going to go down to tangent inverse of 12 divided by 32, which is going to give me 20.556. So theta is equal to 20.556 degrees. Okay, well, the whole point of this wasn't just to get the decimal, but it was also to get the degrees, minutes, and seconds for the theta that I found. So to find your theta, let's go through the steps again. So look at the board if you need to. I have my decimal, Let me highlight it, copy it down, and we need to make it a degree like we have here. So we need to have it as a degree. Remember, you're going to look at the bottom of your calculator, this question mark button that I'm pointing at with my finger. You're going to push that button here, and it's going to come up with a bunch of options of what you want. We're going to hit degree, which is this guy. From there, we are going to convert this to degrees, minutes, and seconds. Your calculator should still be in the same area that it was before when you hit the catalog book here, and it should already be highlighted with degrees, minutes, and seconds. So if it's not, remember, I kind of did this earlier. Let's say for some reason you're back on the first tab. Just tab over until the white box is outlined in black. You're going to arrow over and scroll down to convert to degrees, minutes, and seconds. So just scroll down and it will highlight it in blue when it's selected. We're going to hit enter, and we're going to hit enter one more time. So we're going to have 20 degrees, 31 minutes, and about 22 seconds. So we're going to have 20 degrees, 33 minutes, and 22 seconds. This should be your answer. I'm going to underline the other one too. So we've given you a lot of practice on what you're supposed to be doing for this question. So I want you guys to do one last question before I wrap this up and post the answers. Turn it over to question 19. So on the next page, turn it over to question 19, which is this guy all the way at the bottom. And I want you to do question 19. We've already talked about this. When you are solving for a triangle, you are finding all of the angles and all of the sides. So for this question here, for number 19, I want you to solve it. Go ahead and go. Pause the video, and when you unpause it, I will have your answers posted. And here are your answers. So I did get my degrees, minutes, and seconds. I used my calculator to help me find that number. Literally just took 180 by triangle sum theorem, subtract it from 90, subtracted it from the degrees, minutes, and seconds for the angle that was given. I'm trying my best, guys, to let you see, but hopefully that's visible. And once I got that decimal, I just converted it into degrees, minutes, and seconds, as you can see. And I wrote that down as my answer. And then from there, okay, there you go, that's a lot better. So I subtracted everything by the triangle sum theorem to get my angle, which is also my decimal. So my decimal and angle in degrees, minutes, and seconds, I just put it in two separate forms just in case. For the AC segment, which is this guy down here, so you could have given it a different variable, but I just labeled it as segment AC. I got 83.93. And then for AB, which is the hypotenuse, I plugged that in and I got about 94.76. So all of these numbers you should have gotten. If you have any issues or concerns about it, just feel free to reach out. But these are definitely all the questions that are left over are definitely some good practice for you.